Good morning, I am Devasena. In this lecture, we are going to discuss about Routh'S stability criterion. This topic is present in the subject control system. Now, we are going to solve problems in Routh'S stability criterion. The problem statement is, determine the stability of the following system using Routh'S criterion. This question is asked in an university, May-June 2008. The given g of s h of s value is equal to 1 divided by s plus 2 into s plus 4. The characteristic equation is 1 plus g of s h of s is equal to 0. Now we are going to analyze the given characteristic equation. 1 plus 1 divided by s plus 2 into s plus 4, that is equal to 0. If we solve this equation means we obtain s plus 2 into s plus 4 plus 1, that is equal to 0. If we further simplify the given equation means we get s square plus 6s plus 9 is equal to 0. From this equation we have to segregate the coefficients. The coefficient of s square is a0. Its value is 1. The coefficient of s is a1. Its value is 6. And the constant is a2. Its value is 9. That is, a0 is equal to 1, a1 is equal to 6 and a2 is equal to 9. With the help of these coefficients, we are going to construct Routh'S array. Routh'S array is constructed. In the S1, Sn row, even coefficients are used, and in s power n minus 1, odd coefficients are used. Now we are going to construct Routh'S array. Routh'S array comprises of s power n row, s power n minus 1 row, and it goes on up to s0 row. For construction, in this problem, the maximum power of s is s square. Therefore, we are going to construct s square row, s power 1 row and s0 row. In order to construct s square row, we have to use the even coefficients. That is, a0 and a2 terms are going to be used for constructing s square row. For construction of the s power 1 row, we are going to use odd number of coefficients. That is, a1 value is going to be used. In this problem, a3 value is not provided. Therefore, we have to use 0. With the help of these two rows, s square row and s power 1 row, we are going to determine s0 row. That is, s0 row value is obtained with the help of s square row and s1 row. Its value is 9. For determining whether the given system is stable or not, we are going to go through the Routh'S array first column. The first column of the Routh'S array indicates system stability. If a system has to be unstable, there is no sign change in the first column. If any sign change occurs in the first column, it indicates the system is unstable. In this given problem, there is no sign change in the first column of the Routh'S array. Due to this, the system is said to be stable. Determine the stability of the following system using Routh'S criterion. The g of s h of s is equal to 9 divided by s square into s plus 2. The characteristic equation is 1 plus g of s h of s is equal to 0. Now we are going to construct the characteristic equation. S square into s plus 2 plus 9 is equal to 0. If you simplify this equation means we get s cube plus 2s square plus 9 is equal to 0. Now we have to identify the coefficients of this given equations. the value of A0 is equal to 1, the value of A1 is equal to 2, and the value of A2 is equal to 0, and the value of A3 is equal to 9. Now we are going to construct the Routh'S array. The Routh'S array is being constructed with the help of the coefficients A0, A1, A2, A3, and it goes on up to An. For constructing the Routh'S array, we have to first construct S power n row. The value of the S power n row comprises of even coefficients A0, A2, and it goes on up to An. For constructing the S power 1 row, we have to use the odd coefficients A1, A3, A5, and it goes on up to A suffix n minus 1. This is the structure of the Routh'S array. In this given problem, the maximum power is S cube. Therefore, we are going to construct S cube row, S square row, S power 1 row, and S0 row. With the help of A0 and A2, we have constructed S cube row, and with the help of A1 and A3, we have constructed S square row. Now, with the help of these two rows, S cube row and S square row, we are going to construct S power 1 row. Formula for calculating the value of the S power 1 row is B1 is equal to 2 into 0 minus 1 into 9 divided by 2, that is minus 4.5, and the value of B2 is equal to 0 because there is no value in the B2. Now we are going to determine S0 row. Formula for calculating the S0 is C1 is equal to minus 4.5 into 9 divided by minus 4.5. Its value is 9. Now we are going to determine the system stability. For determining the system stability, the first column of the Routh'S array has to be analyzed. There are two sign changes in the first column of the Routh'S array for this problem. The number of sign changes indicates that much roots are located in the right half of the S-plane. In this problem, we have identified that two sign changes are present. This sign change indicates that two roots are present in the RHS of the S-plane. Hence, the system is said to be unstable.